Rate change problems are intimidating because there's so much information. I have found that it's helpful to organize the information into a chart. So I'm going to draw a chart with two columns. Sorry, my lines are pretty squiggly with this pen. And on the left-hand side, my column is based on the order. And on the right-hand side, the column is based on what we have remaining when we need to recalculate. Now, in both columns, I need to find the same pieces of information, and these will allow me to organize and solve the problem. So the first thing that I need is I need the volume, I need the time, and I need to know the rate. So based on the order, we have 1,000 milliliters as our volume. We have an infusion time of 8 hours. And we're actually given the rate of 42 drops per minute. So I don't have to do any calculating in this column. It's just a matter of organizing the information. The problem then tells me that after 4 hours, you notice that only 400 milliliters has infused. So to figure out the remaining volume, I take the total of 1,000 milliliters, I subtract out what has infused into my patient, and I come up with 600 milliliters are remaining. Now I know that this IV is off schedule because 4 hours is half of the time. So I should expect 500 milliliters to have infused, which would be half of the fluid. To figure out the remaining time, I'll write it out, but you could probably do it in your head. 8 hours total, 4 hours have passed, and so 4 hours remain. To figure out the rate, I'm going to use the formula method. You could also use conversions to calculate this. In the formula method, rate is equal to volume, which is 600, times the drop factor, which is 20, divided by the time in minutes. So my time here is 4 hours, so 4 times 60 would be 240 minutes. And this comes out to be 50 drops per minute. So I have recalculated the time for the IV to end on as scheduled, or excuse me, I have recalculated the rate for the IV to end on schedule. The last question that is asked is what is the percent change? We know that percent change is the amount of change. So I look at the original rate of 42, final rate of 50, that is a change of 8. I divide by the original, which is 42, and multiply by 100. And that gives me a percent of change of 19%. It doesn't ask me for my course of action, but if it did, because this is below a 25% change, it is okay to adjust the IV. These problems look intimidating because of all the information, but organizing them into the chart like I drew here helps you to keep track of the information. This problem was easier than some because the volume, time, and rate for the order were all given. Sometimes you will have to calculate the rate for the order as well as the rate for the remaining fluid.